weeks. Ladies and gentlemen, let me quickly apologize for the delay. We seem to have had some technical errors from our side with regards to the times of the timetables and of course, moving from Teams and back to Zoom. So as a result, unfortunately, there was some confusion in that regard. So I apologize greatly. Ladies and gentlemen, like I've said, we welcome you today for our technology lesson. Welcome, Kia B. Thank you so much for your patience and thank you so much for being here. I see that we have 24 participants who are here with us today. We might not be able to finish this entire lesson, but the great thing is we are still together for the remainder of the entire lockdown. All right, so what is it that is happening today? Let me just quickly browse and go to the next slide. As per norm, for those of us that may not know, but at the end of each lesson, we have what we call an activity in a form of a homework. That activity is meant for you to be able to test any form of understanding or misconception that you might have had for the lesson that was done during that time. Ladies and gentlemen, let's use our Zoom group chat for any questions that we might have so that we can all understand. Buitumelo is asking if this is physical sciences. Buitumelo, no, this is not physical sciences. This is technology grade 7. And I'm just alluding also, Buitumelo, to say there are some errors with regards to the writings on the timetable as well as the links. And we apologize greatly for that. I think largely because we were moving from Teams to Zoom. So we obviously had made some errors in that regard. So unfortunately, we do know that this is not physical sciences, it's technology grade 7. All right, Kiandra, welcome. I see you, I recognize you, and I definitely remember you. Thank you so much for being such a loyal learner and being with us all the time. All right, so let's continue, ladies and gentlemen. Again, I repeat, this is technology grade 7. Okay, so we asked people to draw a rectangle, but in them drawing a rectangle, it must be drawn in the following forms. The first form was freehand sketching. The second form was a 3D oblique. The third form was a single vanishing perspective. Ladies and gentlemen, I'm just going to speak about these as I move them, as I point to the cursor, as I speak to each and every one of them in a way that will be a revision for some people that were here, of course, with us on Friday, and also for people that were not here. So the first one, this is freehand sketching. You will remember that I said freehand sketching, we do not use any other items to draw except the pencil and the pencil only. As you can see, the lines are not all straight, they're not all equal. As you can see, this one is protruded all the way through there. So definitely this is freehand. And we said we use this, why? So that we can get the ball running in terms of our planning and also just, oh, Kiandra, you're not here on Friday because you could not get it. I'm happy that you're here today, Kiandra. That is why we had to go back to Zoom. I see Kiandra is also complaining that, oh yes, actually she's not complaining, she's happy that she learned about the elements of the periodic table. That was when we were still doing natural sciences grade 7. I'm really happy to hear that, Kiandra. All right, so let's move to 3D oblique drawings. Ladies and gentlemen, I said 3D oblique drawings are when the true shape of the object is directly facing the observer. So basically, as you can see, this is the true shape, ladies and gentlemen. The true shape that we're speaking about is the rectangular. However, that shape will have a 3D. What does that mean? It will have 3 sides. I said the D in 3D stands for dimension, and dimension is just a fancy word for sides. So you will obviously have your height, your length, as well as your breadth. So anything that has got 3 sides will have those, ladies and gentlemen. And we can see with the 3D oblique. So already you can see the differences between the two. This is a 2D type of a shape because right here, it's showing us the length. Here, it's showing us the width. However, when we come to the bottom picture, which is a 3D, there are 3 sides to this. We find our length, we find our breadth, and of course, we find our width. So ladies and gentlemen, that would be our 3D. We then go to the last one, which is the single vanishing perspective. That can also be abbreviated as SVP. Now, SVP, ladies and gentlemen, is when the lines, which are called vanishing lines, are narrowing or becoming smaller as you look further into the object. I made an example and I said, if you think about a railway of a train, you will find that where you see the train or where you are standing, the railways of the train or the railway lines are bigger. But as you face across or further down the railway, they become smaller and smaller until they meet at a point that is called the vanishing point or the VP. All right, Mahlatsi, welcome. I see you are still here. Yes, definitely, Ranzu. You can copy all of this. You can draw it in a scribbler. Remember the last time when we actually started these lessons, I said it's advisable for us to actually have a scribbler paper so that when we are saying certain things or there are certain things that need to be noted down, you do that so that you can be able to revise. So definitely I agree with you. Okay, Mahlatsi is asking a question. Mahlatsi is asking the vanishing point. The vanishing point, Mahlatsi, is further onto the object. If you look away from an object, if you look far from it, the vanishing point is where you will see at the end of that point and you can't see beyond it. If you look at this rectangular shape, the same vanishing point would be found here. Good morning, Lifa. Thank you so much for joining us. We are really happy to have you here. Not to worry if you're not here on Friday or the day before. The lessons that were done then, which are obviously pre-recorded, are going to be found on YouTube. So you can simply go onto the YouTube channel of African Teen Geeks and of course, search for Technology Grade 7 and you can be able to have a look at those lessons. Thank you for that great question. Say, how are we going to learn these things when we have 15 minutes? Amu, again, that's a great question. Amu, I will pause wherever this lesson is going to end, and tomorrow I will have to continue because it is not your fault that we had an error in terms of starting late. So don't worry, Amu, we will not rush through things. If we don't continue anywhere, we are going to obviously continue tomorrow. All right, so question number 2. On the left-hand side of the table, we've got the first, second, and third class levers. You will remember that I said a lever is a mechanism that is used to simplify work. So basically, it's when you are trying to do a lot of work with as minimal amount of energy as possible. We had a great example actually in that lesson of what we call the tin or the bottle opener. And we spoke about these things. Again, if you're not here, ladies and gentlemen, please do go back to those lessons. They are found on YouTube. All right, so I want to talk about the fulcrum of a first class lever. I explained, I said the fulcrum is the turning point. It can also be called the pivot. So another name for the fulcrum is pivot. In a first class lever, ladies and gentlemen, the fulcrum is found in the middle of that first class lever. Now, in the first class lever, the effort, just to explain the effort for those that were not here, the effort is the force or the energy that you put in to lift something. So now if you are lifting your bag, your shoulders would become the effort because that is the force that is being exerted by the books which are found in your bag. The load, ladies and gentlemen, for an example, if we are using the school bag example, the load would be the books themselves. So in a first class lever, the fulcrum, which is the turning point, is found in the middle. The effort is found on the left. The load is found on the right. I'm going to go through to this slide, which has got pictures, which are going to make it easier for us to understand. Ladies and gentlemen, as you can see, this is going to be our scissor as an example. So our scissor, the fulcrum is in the center or in the middle. If you have a scissor near you, you can see because that is the point wherein the scissor turns. The load is where you actually push the scissor when you want to cut something. And then the load itself is when you put the paper inside the blades of the scissor. Same applies to the seesaw. In the middle of that, that's where our fulcrum is. That is the turning point. Now, when someone goes down, they become what? They become the effort. When someone goes up, they are the actual load and vice versa. So I want us to go to the second class lever. In the second class lever, the fulcrum is found on the right. The effort is found on the left and the load is found in the middle. Let's go back to that slide and investigate, ladies and gentlemen, if that is the case. So as you can see here on the wheel, this is going to become what? This is going to become our fulcrum because that is our turning point, ladies and gentlemen. That's definitely on the right side of our screens. I'm pointing at it with our cursor. Now, when we are looking at this, we see that this, which are the handles of the wheelbarrow, we are using the wheelbarrow as an example. So that is what is going to become our effort because that's the energy that we put in to lift the load. But where is the load, ladies and gentlemen? The load in any wheelbarrow is found in the middle. That is where we find the cement and everything else. So again, just to repeat, the fulcrum is on our right, the load is on the middle, and the effort to lift, if, for example, the cement is found on the left. So that's second-class levers. Going to third-class levers, ladies and gentlemen, we find that the fulcrum is on the left, the effort is on the middle, and the load is on the right. I want us to go and have a look at this example. As you can see, they're saying lever in which the effort is situated in between the fulcrum and the load. Where is the fulcrum? The fulcrum is right here, as we can see. Where is our load? Our load is definitely here, meaning that this is our effort that is being applied. So definitely when we speak about third-class levers, we are talking about levers where the fulcrum is on the left, the effort is on the middle, and the load is on the right. I made a mistake there. I said road, but the correct answer is actually right. Okay, so the lesson objectives for today are the following. I see that we have about 7 minutes remaining. I'm not going to obviously rush, as I've said to Amo before. We are going to do as best as we can. Welcome, always too good to see you back. Thank you so much. I'm so happy to have you here. I see we are currently sitting on 22 participants. Ladies and gentlemen, I truly appreciate that because I understand that we started quite late. All right. Triple X is saying that they learned something in this class. All right, I am happy to hear that so far, Triple X. I don't know why you are Triple X. I would like to see your name. Tyrone, please kindly put your question or anything else on the group chat box so that we can be able to see and we can respond. All right, so the lesson objectives for today are the following. Number 1, structures. Number 2, natural and man-made structures. Number 3, the uses and the importances of structures. So again, I repeat, structures. Number 2, natural and man-made structures. Number 3, the uses and importances of structures. So I'm going to move on. All right. So before we begin this lesson, these are just some questions that I want you to think about. And I like this part of the lesson because this is where we try to show you that in essence, anything and everything that you learn at school are things that you see every day, are things that you are exposed to, so that when we actually start to do them, you are not surprised, you are not shocked, because these are everyday things. So the first question I want you to think about is that near you, around you, maybe on the side of the bed or the table or the chair or wherever you are, can you see a structure? Anything that you say is a structure near you as you look around the room or wherever you are situated right now? Can you see any example of a structure? That's the first question. Question number 2, now the structure that you are looking at or that you see or that you think is a structure, where do you think it comes from or what do you think is made up of? The last question, why are structures important? What do we use structures for? Oluetu, well done. Oluetu is saying yes, a table. Thank you so much, Oluetu. That is a great answer. A structure example there, Oluetu is the table, and I'm assuming that's where your device is on top of. However, we want to define and explain a structure so that we understand what it is that we are talking about. So what is a structure? A structure is something that is built, made up, or put together in a particular way to support a load. Ladies and gentlemen, I repeat, a picture frame, Lifa correct, is a great example of a structure. So, but what is the structure that we are talking about? We are saying a structure is something that is built, made, or put together in a particular way to support a load. I've just put 2 examples there. I spoke about a school bag, and I spoke about the school bag because that's one of the most common examples of structures that we seldom actually think about. So there is our school bag type of structure. This is another example of a frame structure. This is telling us that there are examples of structures, but the lesson today is not about that. So these pictures are just to show you there are a lot other examples of structures. Oluetu said a table, Lifa said a picture frame, and they are all absolutely correct. Okay, so I want us to move into the classification of structures. Ladies and gentlemen, I see on the clock we have about 5 minutes. Now, we spoke about classification in natural sciences. We said in natural sciences, classification is grouping things or putting them together in a particular way, looking at their shared similarities or differences. So when we are classifying structures, we are simply doing that as well. But now we are looking at technology, as I've mentioned prior, that this is no longer natural sciences, it's technology, grade 7. All right, so we've got 2 types of classifications of structures. The first one are natural structures. Ladies and gentlemen, the word natural immediately gives off what natural structures are. These structures are not made by people. I've put the capital letter not so that we can all see and be clear. So these structures are not made by people, they come from nature. So when nature is definitely up to your own understanding and your own accord. In the natural sciences, when we speak about nature, ladies and gentlemen, we are obviously speaking about trees, we are speaking about animals, we are speaking about people. So that's what nature would be. But basically things that are not manufactured, things that are not created, these things are made or they come from nature. What are these examples? Skeleton, which we study in grade 5, spider webs. Sometimes, unfortunately, these are on top of our roofs, on the ceilings, we always find these, and trees, which are definitely outside. So ladies and gentlemen, these are just examples of structures. So the skeleton that you studied in grade 5, natural science and technology, is an example of a structure. A spider web is also a great example of a structure, and of course trees. All of these are natural structures. They are not created by anyone. You will never find anyone that will say, I created a skeleton. So those are just the examples that are there. Moving on to the second type of classification of structures are man-made structures. So what are these, ladies and gentlemen? These structures are made by people in workshop or factories. Men refers to people, refers to human beings, refers to me and you. So these are made by us in factories or in workshops. For an example, bicycles, tents, shoes, school bags, etc. Okay, so I want us to look at the purposes of structures as we are continuing in our lesson. I just want to see if I've got any new questions. I do not. We are currently sitting on 21 participants. Ladies and gentlemen, let's grow the numbers. Before we left Zoom, we were somewhere around 68. So let's tell our friends to tell their friends and our classmates that we are back on Zoom, and therefore things are going to be much easier as they were before. All right, so purposes of structures or uses of structures, or why structures are important. So purpose or use number 1 is to contain. Interestingly enough, next to me, I've got a mug, and inside the mug, I'm drinking coffee. So ladies and gentlemen, I'm using the mug as an example because the mug is containing the coffee that I'm drinking. If maybe next to you, you are drinking a glass of juice, the juice is being contained inside the glass. So the first thing is that structures contain, they enclose or they keep something inside. That is the first purpose. Purpose number 2, structures protect. So what does that mean? It means that they keep something safe, so they prevent it from being damaged or from being harmed. A great example of what I've put there, ladies and gentlemen, is a tortoise shell. A tortoise shell is a great example of a structure that is used to protect the tortoise itself, because you can hit the shell as much as you want, but if the tortoise is inside, it will not become damaged, nor will it become harmed. Ladies and gentlemen, I feel that I need to end here today. There are 2 more examples in relation to the purposes or uses of structures. We are going to explore these tomorrow as we continue with the lesson. Thank you very much. I hope that you enjoy the rest of your day and the lesson that follows after this. Let me see if Kia is asking something. Kia is asking when the natural sciences test is going to be. Kia, we are still busy with that in terms of setting and moderating it. After it is done, we are then going to definitely give it to you so that you can be able to understand it. Pili, thank you so much. Goodbye to you too. Thank you so much for being here. Remember, the times have changed. I will see you guys tomorrow exactly at 12 o'clock. Bye, Amu, and thank you so much for being here. Goodbye, everyone. Enjoy the rest of your day.